All right, let's go through the 2223 morning quiz review. So first up is particle motion PVA problem. Particle moves along the x-axis so that at time t is greater than or equal to 0. So t value can be 0 or and greater. Okay, so no negative numbers here. Position is given by x of t. At t equals 0, is the particle moving to the right or to the left? So we can plug 0 into the velocity function to determine whether we get positive or negative value. If we get a positive value for velocity, it would mean moving to the right. If we get a negative value for the velocity, it would mean that this particle is moving to the left. Okay? But first, we need to find our velocity function. So starting with our position function, we can find our velocity going through power rule. So t cubed becomes 3t squared. Negative 3t squared becomes negative 6t. Negative 9t becomes negative 9. And then 2 goes to 0. So if we plug 0 into the velocity function and for the t values, in return we'll get 0 minus 9, which is negative 9. So at time t equals 0, the velocity of this particle is negative 9. Negative 9. So since negative 9 is less than 0, we know the particle is moving to the left at that moment in time. Right? Part B, at what time does the particle change direction? So changing direction is a two-step process. We first need to identify where the particle is, where the velocity is 0, or where the particle is at rest. Okay, because we first need to identify where the particle is at rest, because then we're going to have some potential values that we can decide whether those time values when the particle is at rest, whether there's a change in sign. So if there's a change in sign at a moment in time where the particle is changing its sign from either positive to negative or from negative to positive, then that would be where the particle changes direction. So first step, we need to find out where the particle is at rest. So we find the velocity, set equal to 0. So we have our velocity function that we found here. Set that equal to 0. So 3t squared minus 6t minus 9 is equal to 0. We can factor out the 3 and continue factoring. We get, solve for t, we get t is equal to negative 1 and 3. So negative 1 we can eliminate because that's outside of our domain. We're only looking at t values greater than or equal to 0. So now we just have to test to the left and to the right of 3. We can create a velocity sign line, and then we can determine test values between 0 and 3, and then to the right of 3 to determine whether this particle is moving to the left or to the right. So if I choose a value between 0 and 3, let's say I choose 1, then if I plug 1 into the velocity function, I can put it into the factored form. So 1 minus 3 is negative. 1 plus 1 is 2 is positive. So negative times positive is negative. So we know that between 0 and 3, the particle is moving to the left. And then to the right of 3, let's choose 4 as a test point. So plug 4 in for t. So 4 minus 3 is positive. 4 plus 1 is positive. Positive times positive is positive. So at 3, there's a change in signs. So particles moving to the left, it stops and then starts moving to the right. So we know there's a change in direction at t equals 3, since velocity changes from negative to positive. Okay, find all the values when the particle is moving to the left. So by looking at this sign line here, we can tell that particle is moving to the left between 0 and 3. We know at 3, the particle is not moving, because that's when velocity is 0. But we have to be careful here. So we're not going to include 3, okay? But we have to be careful here with 0. Normally we would say just parentheses from 0 to 3. But look at our domain here. Our domain is t is greater than or equal to 0. So that tells us that we have to test 0. There may be motion at 0 that we have to be aware of. So if we plug 0 into the velocity, okay, we know the velocity actually here, right? Velocity of 0 is negative 9. So actually at time t equals 0, this velocity is moving. So it's moving to the left since we see that it's a negative value. So we have to say the interval will have to include 0 as a point where the particle is moving to the left. So 0 inclusive of 0, and then parentheses around 3. So bracket at 0 and parentheses at 3. Find all the values where the particles move to the right. So moving to the right is from 3 to infinity, since there's no endpoint. So parentheses 3 to infinity, since that is when velocity is positive. Number 2, determine the x-coordinates in which the graph of the function has a horizontal tangent line. So horizontal tangent line, we can determine this by finding the derivative and setting the numerator of the derivative equal to 0. Okay? That's when where the tangent line horizontal tangent line will occur. Vertical tangent line will occur where the denominator of the derivative is equal to 0. But the horizontal tangent line is where the slope is equal to 0, and slope is equal to 0. If there's numerator and denominator, we're only looking to see values of x that will cause the numerator to be 0 and therefore the derivative to be equal to 0. So here's f of x. To first find, we first need to find f prime. So to find f prime, we look at what we're given. We have numerator over denominator, so probably the best way is to go through quotient rule. So f prime g minus f g prime all over g squared. So we're going to go through product quotient rule here. So f prime is the derivative of the numerator, so x squared becomes 2x. We keep the denominator value, x minus 1, that's the g function, minus f, which is the original numerator, x squared, times g prime. So g prime is the derivative of the denominator, so x minus 1's derivative is 1, all over denominator squared. And if we clean this up a little bit more, we can distribute the 2x through. We get 2x squared minus 2x minus x squared, which continues to simplify to be x squared minus 2x all over x minus 1 squared. Now we have our derivative simplified. Now we can look for the horizontal tangent line. So horizontal tangent line where the slope is 0, we're going to set the numerator of the derivative equal to 0. So I can factor the x times x minus 2. Solve for x, we get x equals 0 and x equals 2. Okay, so we found our x coordinates here. And if we were to find the slope of those lines, of those horizontal tangent lines, then we can plug 0 and 2 back into the original equation. If that's the case, we get 0 over negative 1, which is 0. And if I plug in 2, we get 2 squared, which is 4, over 2 minus 1 is 1, so 4 over 1 is 4. So the tangent line equations, which doesn't quite ask you for that, but I just want to take this problem a little bit further. The tangent line equations will be y equals 0 and y equals 4, since these are horizontal lines. All right, number 3, we're given y is equal to 2 minus x over 3x plus 1. It's asking for dy dx. It's asking for the derivative. So again, looks like this is a setup for quotient rule. So f prime g minus f g prime all over g squared. So f prime is the derivative of 2 minus x, which is negative 1. And then times g, we keep the denominator, minus the original numerator, times g prime. So the derivative of the denominator is 3. We can distribute and clean up the numerator, and negative 3x minus 1 minus 6 plus 3x. The 3x is canceled out. Negative 1 minus 6 is negative 7. So there's our derivative. So that matches with option A. Number 4, find the equation of the tangent line. So to find the equation of the tangent line, we're going to have to find the slope and the ordered pair. So to find the slope, we need to first get to the derivative. So the derivative, again, quotient rule. So f prime g minus f g prime, f prime g minus f g prime all over g squared. I can clean this up a bit more here. I'm left with negative 7 over 5 plus x squared. Okay, so now if we want to find the slope, we can evaluate the derivative at 1. So if we plug 1 into the derivative, we get negative 7 over 5 plus 1 squared, so 6 squared. So negative 7 over 6 squared is negative 7 over 36. We have our slope. Okay. And then the next thing is we need to make sure we have an ordered pair. We know what the x value is. So to find the y value, we can plug the 1 into the original equation. So we get 2 minus 1 over 5 plus 1 is 1/6. So we have our ordered pair, which is 1/1/6. We have our slope, which is negative 7 over 36. And now we can take that information and put it into point slope form. So y minus y sub 1 is equal to m times x minus x sub 1. So y minus 1/6, that's the y value, is equal to the slope, negative 7 over 36 times x minus the x value here, minus 1. All right, last one here. Given f of x, so we have f of x in various with terms in various forms. Find f prime. So looks like all these will be able to be used by power rule. But if we want to use power rule, each of these terms need to be set up in order for power rule to be applied. So power rule requires that the variable is sitting up in the numerator and also combined nicely. So here we have 4x cubed over root x. We can simplify this we can bring the x up as x to the negative 1/2. So if we bring this up as x to the negative 1/2, we're going to subtract the exponents. So 3 minus 1/2 is 2.5 or 5/2. So here we have the cleaned up version of the first term. We have to get this in preparation for the restrictions that we need to apply power rule. All right, here 3x times the 5th root of x. So 3x times the 5th root of x. That's the same thing as think of this as x to the 1/5. So x to the 1/5 times x to the first power. Same thing as adding fractions. So here we can find common denominator of 5 over 5 plus 1 over 5 would be 6 over 5. So 1/5 plus 5/5 would be 6/5. So we're able to combine these terms together so we can use power rule. So 3x to the 6/5. And then next, we can't do power rule for these terms yet because we have x that needs to be distributed through. So we can distribute the 6x cubed through. So if we multiply 6 times 2, it's negative 12, and then x cubed times root x, the same thing as x to the third times x to the 1/2. We add exponents. 3 plus 1/2 is 3.5 or 7/2. And then distribute the 6x cubed to the 4x. We get positive 24x to the 4th. And then the minus 4 pi x is ready for power rule, and 3.99 is as well. So first step is we're just algebraically trying to clean up our expression so that we can apply the power rule nicely and cleanly. Now we're ready for the power rule. So power rule, for derivatives, we can bring down the 5/2 and then subtract 1 from the exponent. So 5/2 minus 2 over 2 is 3 over 2. Next term, bring down the 6/5 and then subtract 1 from the original exponent. So 6/5 minus 5/5 will be 1/5. And then next term, bring down the 7/2, subtract 1 from the original exponent. So 7/2 minus 2 over 2 is 5 over 2. 24x to the 4th. So 4 times 24, x cubed. X cubed is coming from the fact that we have to subtract 1 from 4. So 4 minus 1 is 3. And then 4 pi is the coefficient for the x. So the derivative of a linear, it will just be the coefficient. So 4 pi x becomes simply 4 pi. Remember, pi is not a variable, it's just a number. 4 pi. And then 3.99 is a constant. The derivative of a constant is 0. So make sure we don't forget to also apply the derivative for the constant. So we found the derivative. Now it's just a matter of trying to clean this up a bit more. So 5/2 times 4 gives us 10. 6/5 times 3 is 18 over 5. 7/2 times 12 is negative 42. 4 times 24 is 96. And here we have our derivative function.